And hello, welcome to this video. In this video, I'll be showing you how I install LabVIEW on Manjaro using Docker. Now, this video will be broken into two parts. Okay, first is the too long didn't read, too long didn't watch part. Okay, and then the second part is the part where I explain, the thought process of getting to these instructions. So if you want the quick answer for installing LabVIEW 2020 on Docker, OpenSUSE, this is the answer. Okay, I will spend some time explaining this first, and then what? Yeah, and then we will go into the long explanation where I try to explain the thought process. Okay, I think we'll explain the thought process and try to walk you through how to think about this, because even these too long didn't read, too long didn't watch instructions, they will become obsolete after a while, and you got to know how to think about think of how to debug your own situation. Okay, so let's start. Okay, so the instructions for the too long didn't read, too long didn't watch are as follows. I will not be doing a demo. I will not be doing a demonstration here. Okay, first your first instruction is to install OpenSUSE Leap, not Tumbleweed. Okay, OpenSUSE Leap, version 15.2. This is the latest version, I think, supported by LabVIEW 2020. You can try Firefox as per the instructions used in the previous videos. Remember to use the net equals host environment equals display. You should be able to do this without any issues. Your next step is to install some dependencies. Zypper install -t pattern devel basis. This is the equivalent of base devel for Arch, and base devel for Arch, and build essential, whatever. Okay, so just install all of this. This is a very important library. You need to use the Xinarama. I don't know how to pronounce it. Okay, FreeCAD is good. I mean, it has a lot of libraries which are installed along with it as dependencies. You may need some of them for OpenSUSE. So anyway, NeoFetch and Vim are good tools to have anyhow. You can also install Firefox, but this is more for testing the visual server, so to speak. Okay, your next step is to mount the LabVIEW ISO. Now, by default, you will not be able to mount ISOs. If you copy ISO files into Docker programs, or Docker containers, or aka instances or containers as they like to call it, you will not be able to mount them. You'll say even as you run it as a root inside the Docker container, you will not be allowed. Reason is it's a security measure. So you have to start your Docker container with the privileged flag over here. So just add this flag along to all the flags. So this is assuming you know how to use some sort of Docker. Okay, so then after that, after mounting, you will then go into your LabVIEW and you install the scripts, and then you can run LabVIEW by running LabVIEW 64. This is the too long didn't read, didn't watch option. Okay, I'll be going into the debugging part next, so you can try this out first. If these instructions don't work for you, maybe come back to this video, watch me explain as I walk through, and then maybe you can get LabVIEW installed. Okay, so now I'm going to try the longer explanation route. Okay, I'm going to show you the debugging process. So this will take long. I want to prepare your expectations. This will take long because I want to explain the whole thought process of getting there. Now, let's run Docker first. Okay. So let's try to have a vanilla OpenSUSE. So remember, use the net equals to host, environment equals to display. This is what we learned the last time. Okay, and then what do we run? OpenSUSE. Okay, you run your test code. Okay, and then you say Alright, we are unable to find any OpenSUSE images. Okay, why is that so? Because you need to specify what OpenSUSE you want to run. Okay, so let's try OpenSUSE Docker. If we Google it, it says that OpenSUSE is actually deprecated. Okay, you need to actually download OpenSUSE Tumbleweed or OpenSUSE Leap. Okay, so you have to use OpenSUSE / Tumbleweed if you want to download Tumbleweed. Now, my first instinct is, of course, to actually do OpenSUSE Tumbleweed, because for me, I like what do you call that? I like very much the concept of rolling distros, which is why I prefer Manjaro and Arch-based distros as compared to Debian-based distros. Okay, and of course, Manjaro looks aesthetically pleasing to me. I like the aesthetics of it, so all the more I will stick with it. So now this is OpenSUSE Tumbleweed. So we can actually zipper install NeoFetch. And we can just see whether this is really the Tumbleweed OS that we are talking about. So installing OpenSUSE Tumbleweed is not that difficult. Okay, I just do a zipper install, and you can already see zipper is working. Zipper is the equivalent of apt in Debian-based distros, and Pacman in Arch-based distros. Okay, so let's do NeoFetch. Okay. All right, so we are able to let's run NeoFetch properly and see we are running OpenSUSE Tumbleweed. Okay, we go to home, you'll see a blank home directory, which means that you're in the right place. Okay, of course, I would like to vim my bash rc, which means I need to install vim. Okay, I want to change my aliases because I like to use the alias L for LSCF. It's a very knee-jerk habit of mine. Alias L equals to LSCF. Okay, then I'll source the bash rc file, and yeah, I'll be able to use vim. Okay, vim. All right, so yeah, what's next? Okay, yeah, we have NeoFetch, and yeah, we have NeoFetch, right? So what's our next objective? Okay, we have already so-called got our OpenSUSE distros running. Now we want to get, okay, we're gonna copy both our LabVIEW ISOs in. Okay, normally, yeah, the vanilla LabVIEW is a LabVIEW 2020 Linux ISO. However, I usually use it with the control design and simulation, which I'll not show you in this video, but maybe in some other video. Let's just Docker cp, Docker copy our LabVIEW ISOs in. Okay, I'm going to copy both of them. So open a new terminal. Let's go to desktop. Okay, and these are the ISOs I want to copy in. All right, and let's do sudo docker ps-a, and this is the container ID. Okay, and the name of this container is called determine DaVinci. So just take note, determine DaVinci is the one. Okay, so docker ps-a, this will actually give you determine DaVinci. So let's do docker cp, and remember this is the syntax we need to use: container, source path, container destination path. I want to put it in home, and then I want to create a LabVIEW folder. Okay, make directory LabVIEW, and let's paste. Let's put our stuff in LabVIEW. So sudo docker cp LabVIEW 2020 full Linux ISO, and I want to put it inside the where? I want to put it inside this determine DaVinci container, colon home lab view. Now I'll put it there. And let's list it here. Our ISO is here. Very nice. Next thing is, I also want to copy my control design and simulation. CD and sim. Again, the same place. Okay, so pretty simple, straightforward if you're already familiar with Docker CP. Okay, next step. Okay, next step is what we need to do. We need to mount these ISOs. So to mount, we actually need to make a directory. So I'll just make it here because I'm lazy. And let's try typing the mount command. It will say the mount command is not found. All right. Why is the mount command not found? Yeah, because I guess this is a very minimal image of OpenSUSE. So what we need to do is zipper install t -t pattern devel basis. Okay, where did I find this from? So if you type what is the base devel or build essential equivalent of in OpenSUSE. Okay, in SUSE world, there's no such thing as build essential. So okay, there's no such thing as build essential. So what you need to do is this pattern devel basis. Okay, this will give you all the packages you need to install. That will include your mount package. So see, you have auto conf auto make bind utils, bison, cpp, flex, gcc, everything you need to start building your thing. Okay, so you see patterns based system. I don't know what. There are lots of things here. So the command used here is zipper info -t pattern devel basis. Well, if you do a zipper install, all of this, you will be able to mount, or at least execute mount commands. Okay, I will just press Y. Okay. So it will just take a while. And as you notice, I'm actually not on my slow computer. I'm on my slightly faster computer, so that it's a little less frustrating to make the videos, because that slow computer is really slow, but it's still possible to install LabVIEW on that. But yeah, to demonstrate all the walkthrough, it's better to do it on the fast one. Anyway, my Docker images here are kind of new, so it's fine. Okay, so we'll be installing like 99 files and all that. Okay, so again, don't worry about all these things, all these links. I will just paste it in the description. You will be able to see them. Okay. So yeah. So just one note: if you want to install things and you just want to confirm it in apt, you use the -y flag. Okay. If you use zipper install, you can also use the -y flag. For example, Firefox. Okay, but you say, if you look here, Firefox is not found in package name, try capabilities, blah blah blah. -y is not found in package names, try capabilities. Okay, basically, this is the thing. Okay, if you put the -y after, OpenSUSE, the zipper will think, this -y actually is an extra package which you need to install, which is not true. Okay, so let me exit from this. The proper way to do it is to actually put the -y flag in the front. So zipper install -y Firefox. So these are some of the packages. See, now everything will install smoothly. So this is Firefox. Okay. Anyway, so that was the demonstration. You will install Firefox pretty quickly. But yes, now for the important part. Okay, we still need to get back to mounting. Okay, so almost there. Oh wow. Okay, it's still installing. Yeah, let's get back to mounting. So how to mount ISOs in Docker. Okay, so this is very tricky. Okay, inside Docker. Okay, so actually, yeah, if you try to mount ISO inside a container, you will get this you will get some problems. And of course, the command to mount is to just mount. Remember to use the option of loop. Okay, you have to let's see. I think this is the best. Let's see whether we can find privilege. Oh boy. Mount ISO. Yes, okay. I think this is the best page. Let's say, is there any way to mount ISO contained within Docker? Okay. All right. Is there any way to run this? Okay. I think I forgot the. Hold on. I'll be back. Yes. So I was trying to say yes. Mounting images within Docker containers is a bit more tricky. So you'll need to make these loopback devices. I have no idea at this point. Okay. What exactly is going on behind this whole loop thing? But okay, just take the commands as they are. We usually use when we usually mount partitions or mount whatever, we use the option -o loop. Okay, how to mount ISOs. Okay, the way to mount it is to actually use this option loop. Your first input is the ISO path. The second input is your mount point. So if we want to try this, okay, if we made a directory mount just now, I can actually try to mount this LabVIEW ISO in. So mount, okay, mount is now running, so it's very good. Mount -o loop, okay. Okay, the standard way is to do it like this. I didn't look in detail as to why you must do this, but this is the syntax you use. Mount -o loop, okay. You mount the you type your ISO file, and then you type the mount point. So this is the mount point. So this is just here so we can access all the files inside. And of course, you will see here, the mount will fail because operation is not permitted. Why is that so? Okay, after some research, I found that hey, you need to actually give some privileges. Okay, so mounting a disk in Docker, okay, credit to this website called SigCodes. Okay, mounting the images inside Docker requires 2 steps. The first step is to give Docker container evaluated permissions. Okay, to create loopback devices that are both inside and outside the container. The second is creating a loopback device inside the container. If you don't want to use elevated permissions, you have to see below the first example. Okay, you cannot use loopback devices without the privileged tag. So whenever you want to start mounting stuff within your container, you need to use this privileged flag. Let me demonstrate. So I'm going to exit this. Now, of course, I'll need to sudo docker commit. Let's ps-a first. I will actually get this one. Sudo docker commit. No message there. Open SUSE tumbleweed. Okay. I'll just make the tag tumbleweed there for reasons you will see later. Okay, because now there are so many branches of OpenSUSE, I don't want to, yeah. What's there's tumbleweed and there's leap. Okay, so I don't want to make the confusion between them. So let's try running it with the privileges now. Sudo docker run it net equals host what environment equals display, and let's do privilege. Okay, then we run open SUSE tumbleweed. Okay, bin bash. This one, the last part's of course optional, but you can run it. Okay, and we're here. And let's go to home. And let's go to LabVIEW. We should be able to mount this time because we gave it extra permissions. Loop. LabVIEW 20 ISO, and mount. Okay, so now we are able. So remember, always use the privileged tag. Okay. Okay, the next part is a bit strange when we start to install this LabVIEW. So what we do is to go to the mount point and we just start the install script. Okay, you just go through LabVIEW and you look at this error. Invalid signature tag. Okay, invalid signature tag. Archive size, blah, blah, blah. So, okay, it will say eventually we are not really able to install LabVIEW. It says error installing packages. Check that you have enough disk space in the target file system. Okay, so basically we have all these errors, especially LabVIEW core is not installed because of this error called invalid signature tag archive size. Let's take a look at this error. Where does it come from? Okay, you can see that this is actually a relatively recent error. This is not the first time it happens. Okay, they call it a regression error. Basically, what happens is that some of these RPM packages, RPM is a Red Hat package manager. RPM packages, which you kind of need OpenSUSE to deal with, or you can use Red Hat Enterprise Linux or Fedora. Okay, these packages are pretty old. If you take a look at this what do you call it, issue, basically these packages are pretty old. You can use an older version of RPM or Red Hat Package Manager to install this. Okay, but if you see RPM version within Tumbleweed, okay, RPM version here is 4.16. Okay, so this problem only occurs with Red Hat Package Manager 4.16, whereas in earlier versions of the Red Hat Package Manager RPM 4.15, you will not have this issue. So the question then is, how can we, okay, so after some research and all that, the question becomes, how can we actually shift to an earlier version of RPM? Okay, how do we shift to an earlier version of RPM? Okay, so the thing is that we want now to install earlier version of RPM. So the only place with an earlier version, well, you don't look on Tumbleweed because Tumbleweed is a bleeding edge distro. Okay, when you for the OpenSUSE family, Tumbleweed is the leading edge distro, whereas the Leap versions are more stable. So you will have a better chance not in OpenSUSE Tumbleweed, but in OpenSUSE Leap. Okay, so I'm going to just exit out of this, and we'll need to sudo docker run it. Let's do an OpenSUSE Leap distro. So let's do net equals host and environment equals to display. So oops, environment equals to display. Let's give it a privilege tag so that we apply what we just learned, and we'll do OpenSUSE Leap. Let's give it the version 15.2, and they'll say, oh, we cannot find it locally, so they'll pull it from the web and they'll extract it, and we'll be over here. So we can again zipper install. Now we use -y vim Firefox, yeah, or vim and what? We did NeoFetch. And remember, we did our base development, but it's not base development this time. We use this zipper info zipper install t pattern devel basis. So this is what we need to do the mount points. Okay, so next thing, of course, we want to Docker copy in things. So let's do sudo docker ps-a while all the updates are running. Okay, so we'll let them install. We'll need to install this into OpenSUSE Leap 15.2. So this is called the Flamboyant Booman. Okay, so all right, Flamboyant Booman. Let's install some not so not so flamboyant LabVIEW into you. Yeah, sudo docker copy LabVIEW blah blah blah. 2020 Linux as ISO. Let's put this into the Flamboyant Booman. Oops. Okay, Flamboyant Booman. And then let's make a LabVIEW directory. And before that, yeah, let's go to make a LabVIEW directory. cd home, make directory mkdir. What am I doing? LabVIEW. cd LabVIEW. I wonder why all my font colors are changing, but anyway, home LabVIEW, and let's also do the same for the other cd and sim. Okay, let's put it here, and then our dockers are here. Make directory mount, and let's install all of this, the devel basis patterns. Okay. Okay, we will need to do that. Now, of course, we can fast forward it a while. Okay, yeah, but okay, long story short, what we are doing here is that, okay, Tumbleweed doesn't work, so we need to go to OpenSUSE Leap, where hopefully there's an earlier version of the Red Hat Package Manager. So to check that, I guess once this is installed, then we can, yeah, it's almost 27 minutes. Yeah, once this is installed, the next step is to check the versions of Red Hat Package Manager. Okay, so of course, the whole process of debugging and finding out what's wrong, it took very long. I'm just presenting to you the results. Okay, so yeah, so I'm installing this. We can do a Docker commit later after LabVIEW is installed properly. Yeah. Okay, so RPM version. Okay, you take a look at this. RPM version in OpenSUSE 15.2 is actually 4.14. So this is actually safe to run LabVIEW, in theory at least. Okay, based on what we found out just now, because yeah, sometimes usually Tumbleweed will be able to run LabVIEW, but it's not officially a supported version. Only Leap is supported. Okay, so this is one of those times where Tumbleweed cannot run LabVIEW. Okay, so this is the thing. So anyway, let's try mounting first. Let's using the option of loop, LabVIEW 2020 ISO. Again, this is something I just copied from the internet, from those guides. I don't really fully understand what's going on, but we'll use it anyway. Okay, so let's give it the mount point here, and now it's mounted. Let's go to the mount point. Okay, I don't have my favorite L command, so let's L alias L equals to ls-cf source -rc. Okay, so let's install. So LabVIEW should be able to install this time. You see, now all the things are okay. So you just type yes to all of them. Yes. So you see, LabVIEW is now installing in Docker. All right, so we'll let LabVIEW install a while. And of course, as you would guess or realize, there are lots of missing libraries. Okay, so now LabVIEW installation is complete. There are no failure messages or anything. So I don't want to view the LabVIEW 2020 upgrades, and voila, we are installed. Okay, so now that LabVIEW is installed, how do we run LabVIEW? We use the command LabVIEW 64 for this case, and then we can start running. Okay, LabVIEW 64 will just complain, you know, there's an error because there's no shared libraries. So we'll need to install some of those libraries. You know, my standard modus operandi is to zipper search. Yeah, my standard method is to zipper search libcinerama. Okay, so I'll just install the libcinerama devel. Okay, so instead of zipper search, we can do zipper install. Let's do the devel. I forgot my Y key. Okay, so these are the dependencies you will need to install, which is why you will see me putting libcinerama devel at first. FreeCAD is just for all the other libraries you might need, but yeah, if we can run LabVIEW without running FreeCAD, sure. But yeah, during my first round of running this, I installed FreeCAD as a precaution just to avoid some headaches. But let's see whether we can run LabVIEW anyway. See, lots of missing libraries. Now libgl SO1 is missing, so we will need to install FreeCAD. Not because we really want FreeCAD, but because we want all the dependencies that come with FreeCAD. So we'll install like 200 libraries, which will give us sufficient libraries for LabVIEW to run. Okay. So this is the first test of LabVIEW, but you know, we need to install dependencies. So I'll just give it a little bit of fast forward. All right, now that we have installed our dependencies, I fast forward the thing. Let's actually run LabVIEW 64. Okay, and now LabVIEW is running. Okay, so let's try doing a VI. So I'll just create some project. LabVIEW 2020. Okay, so we are able to run LabVIEW without the use of virtual machines. We can run it with OpenSUSE and Docker. You know, of course, it'll take a while. Let it take a while. Yeah, so yeah, that's a lot of things we actually covered over here in one video. Now, normally I like to keep my videos under 20 minutes, but yeah, never mind. Today is an exception. I am not going to. So let's make a blank VI. Okay, and you can see that we have a blank VI here we can use. The fonts are not as nice as I'd like, but no complaints otherwise. Everything seems to be working pretty decently. Okay, so let's just make a slider over here, vertical pointer slide, and we'll make an indicator, numeric indicator, and then behind the scenes here, we'll actually just do a times 50 or something, just to test some LabVIEW functionality. Okay, because this will take some time. LabVIEW will be compiling as you run it. I guess that's how it works. Let's just do a 50 multiplication factor thingy, and then we'll just save this random VI somewhere. Okay. Then of course I want to put a while loop here, and we'll just do wait. I'll give 100 milliseconds to wait, and I'll create a control to stop. We should be able to run this VI very quickly. Okay, so we can save the VI somewhere. We'll not save it under mount, of course. We can save it under LabVIEW. Let's make a new folder, test projects. Let's make a new directory, and we'll save it as my test VI in Docker. Okay. So let's save it here, and we can just click run, and you can see that this LabVIEW's working very nicely for us. Okay, so I'm gonna stop the VI. I'm gonna close both of these, and you can see that LabVIEW is now working. Okay, so if we exit, we can actually do some docker commits, sudo docker ps-a. Okay, so we just do some docker commits. This is the flamboyant booman. Okay, sudo docker commit flamboyant. Oh, not the flam. We'll use a container ID to avoid ambiguity. OpenSUSE Leap. Alright, so we have successfully installed LabVIEW. I'm just doing some housekeeping over here. Doing the Docker whatever, you know, Docker commits, the Docker system prunes. That should be fine. Okay, sudo docker ps-a. Okay, so these are some of the containers we will need to exit once this commit is over. Of course, it will take a while to commit because it's a bit bigger. Okay, sudo docker system prune. Yes, please. And you'll say our reclaimed space is about 7 gigs of data. Fair enough. Okay, so that's what we can do. Sudo docker images. Okay, so you can see that the Leap image is about 4 gigs, Tumbleweed's 2.05. I don't really have much else here. Okay, I have my Ubuntu image here, the latest. Okay, but as you can see, I don't really need my Tumbleweed image anymore. So I'll just sudo docker image rm. Let's remove the Tumbleweed image. Okay, sudo docker images. Okay, and then sudo docker system prune. Okay, so nothing there. Okay, and that's all I have for you this video. Hopefully you found it useful to run LabVIEW within a Docker container. I've not shown you the control design simulation part yet. But yeah, that should be comparatively easier than this part because there are lots of steps to go. Okay, but we did it without a virtual machine, and that's helpful if you want to save on overhead, on what do you call it, processor overhead, RAM, and everything. And this will be essential if you want to run it on a low spec computer. You run it very fast as well with native speed. Okay, you don't need a virtual machine to do it. It'll be faster for you. Alright, so thanks for watching. I'll see you again. Bye bye.